Geometry, Chapter 8, Lesson 2, and we want to actually kind of begin our introduction of trigonometry by looking at two special types of right triangles, and those are the 45-45-90 triangle and a 30-60-90 triangle. So now those numbers represent the measure of the angles. But before we do that, I want to review some of the things we know about right triangles, because we're going to use those properties to begin investigating these special triangles. So to review, you remember in a right triangle we have the angle, the right angle, that's what makes it a right triangle. The leg that's opposite of that is called the hypotenuse. The two other legs of the triangle are simply called legs. Now it's very important that you understand that vocabulary, because when we talk about these 30, 60, 90s, we're going to be using hypotenuse and legs a lot. So it's important that you understand that when we're talking about the legs of a triangle, we're talking about the two legs that are not the hypotenuse. And when we say the hypotenuse, that you know where to locate that, that's opposite the right angle. So vocabulary that you've seen before, but some vocabulary that's very important that you understand moving forward. Additionally, we learned that with a right triangle, we have the Pythagorean theorem that one leg squared plus the other leg squared will equal the hypotenuse squared. So leg squared plus leg squared would each equal the hypotenuse squared. And we're going to use that relationship in our discussion of these special right triangles. Now, another thing I want you to remember is a theorem that we had earlier this year, that if the sides of a triangle are not equal in measure, then the longer side is opposite the larger angle. So if we have these three angles in our triangle, the larger angle, the side that's opposite that larger angle, is going to be the longer leg. And then the next largest one opposite that would be the next largest leg, and the smallest angle will be opposite the smallest side. So it's important that we understand and remember that theorem as well moving forward, because again, we're going to use those when we start discussing these special triangles. So now that we've done some review of the vocabulary, let's take a look at some of the properties of the 45-45-90 triangle first. Now in a 45-45-90, the numbers represent the measure of the angles. And based upon what we just talked about, because both of these angles are the same and the sides that are opposite the larger angle is larger, because the angle measurements are the same, these legs in the 45-45-90 are going to be the same measure. And then the hypotenuse, again, is opposite the right angle. So that would be over here. So if we apply the Pythagorean theorem, if we make one of these legs a length of 1, the other length will also be a 1 because the sides are the same. We apply the Pythagorean theorem, 1 squared plus 1 squared will be equal to the hypotenuse squared. And so 1 squared is 1 plus 1 squared is 1, that's 2, and then that's 2 is equal to the hypotenuse squared. You take the square root of the hypotenuse then to unsquare it, and you end up with a hypotenuse of square root of 2. And what this does is it establishes a relationship that's always true for every single right triangle that's a 45-45-90. And that relationship is this, is that the hypotenuse is always equal to the leg times the square root of 2. So if I have a 45-45-90, the simple equation that I can always have in place or have in mind that I can use is that the hypotenuse will always equal the length of the leg times radical 2. So using this, or understanding this, gives us this little equation. The hypotenuse is equal to the leg times the square root of 2. And applying a little algebra, solving this for the leg, we can then get that the leg is equal to the hypotenuse divided by radical 2. And that's just an algebraic manipulation of this, where we solve for the leg, so we divide by what we don't want, and that is the square root of 2. So in a 45, 45, 90, there's one equation to remember. The hypotenuse is always equal to the leg times the square root of 2. And a second property of that is that both the legs will always be the same measure. Okay? So we can use that then to solve for different lengths in a 45, 45, 90 very quickly without having to go through the process of applying the Pythagorean theorem, because this equation is true for every 45, 45, 90 triangle. So let's take a look at a couple of quick applications of this. Here I'm given a triangle. It's a 45, 45, 90, so there's two things that I want to remember. Both the legs will be the same length, and the hypotenuse will be the leg times the square root of 2. So as I look at this triangle, I notice that this is my right angle, so h is opposite of the right angle, so h is my hypotenuse. The value of 9 is the length of one leg, and so the hypotenuse is going to be this leg, 9, times the square root of 2. And so the length of the hypotenuse in this case would be 9 square root of 2. Again, simply multiplying that by the square root of 2. In this example, again, I notice that this is a 45, 45, 90. X is across from the right angle, so that is the hypotenuse. I notice that the leg, it has a length of 2 square root of 2, so what would be the value of x? Well, what I have to remember is that in order to figure out what the hypotenuse is, okay, I simply take the leg, whatever it is, and multiply it by radical 2. The hypotenuse here is x, so x is going to be equal to the leg, which they give me as 2 square root of 2 times the square root of 2. That's the property of the 45, 45, 90. So x is going to be, the radical 2 times the radical 2 is a 2. That's two radicals that are the same. So 2 times 2 would be 4. So the length of x here in this problem would be 4. And I have a length of 4. Okay, one more example for this 45, 45, 90. In this example, again, I have a 45, 45, 90, so immediately what two things I know is that the hypotenuse is going to be equal to the leg times square root of 2, and I also know that the legs are equal. So if I remember those two properties, I simply apply the one that I need for the situation here. Now in this case, the 6 is across from the right angle, so 6 is my hypotenuse, and they want me to determine the value of x, which is a leg. So I'm going to use my relationship and substitute in the value where it goes. The hypotenuse is 6, so I'm going to substitute in 6. And I need to know what the leg is. That's x times the square root of 2. So I simply solve for the square root of 2. So x is going to be equal to 6 divided by the square root of 2. Now I need to rationalize this denominator, so I'm going to multiply it by the exact same square root in order to make this a rational number. So this is going to give me 6 square root of 2, and then these two radicals that are the same multiplied together are going to give me 2, and then I can simplify these numbers that are outside the square root, so that's going to give me 3 square root of 2. So my simplest radical form answer here is 3 square root of 2. So those are the properties of a 45, 45, 90 triangle. And in the next lesson, we'll look at the properties of a 30, 60, 90 triangle.